The deadliest natural disasters science says are overdue. Imagine waking up tomorrow to discover that the world you trusted has been living on borrowed time. Not because of a war. Not because of an asteroid. But because Earth itself has been quietly preparing for disasters that scientists have been expecting for decades. Some are centuries overdue. Some could happen tomorrow. Others may wait another 100 years. The terrifying part is that no one knows exactly when the countdown reaches zero. Hidden beneath oceans, enormous tectonic plates continue to grind against each other, storing unimaginable amounts of energy. Volcanoes breathe almost imperceptibly beneath glaciers and forests. Massive faults remain eerily silent, not because they're gone, but because they're building pressure. History tells us something unsettling. The longer certain natural systems remain quiet, the more devastating their eventual release can become. Scientists around the world constantly monitor these sleeping giants using satellites, GPS networks, deep earth sensors, ocean buoys, and sophisticated computer models. Their goal isn't to predict the exact day disaster will strike, because that's still impossible, but to identify where nature's greatest risks are accumulating. And what they've found is enough to keep emergency planners awake at night. Today, we're exploring 10 of the deadliest natural disasters that science says are overdue, not guaranteed to happen tomorrow, but serious enough that experts continue to prepare for them. Let's begin where one of Earth's largest ticking time bombs lies hidden beneath the Pacific Ocean. The Cascadia subduction zone stretches for nearly 700 miles along the western coast of North America, from northern California through Oregon and Washington into British Columbia. Most people have never heard of it. That's surprising because many geologists consider it capable of producing one of the most catastrophic earthquakes in modern history. Unlike California's famous San Andreas Fault, Cascadia has remained almost completely silent since European settlement. At first glance, that sounds comforting. It isn't. This fault is locked. Instead of releasing pressure through frequent moderate earthquakes, enormous sections of the tectonic plates are stuck together. The Juan de Fuca plate continues diving beneath the North American plate, storing strain year after year. Researchers estimate the fault has produced magnitude 8 to 9 earthquakes many times throughout history. The last one occurred on January 26, 1700. No written records existed in North America then. But the evidence survived. Japanese historical documents describe an orphan tsunami that mysteriously struck their coastline without any local earthquake. Tree rings from drowned coastal forests in Oregon match the exact timing. Sediment layers reveal giant tsunami deposits stretching far inland. Indigenous oral histories also describe violent shaking and massive waves that transformed entire coastlines. Together, these independent lines of evidence solved a centuries-old geological mystery. Today, more than 3 centuries have passed. That doesn't mean the earthquake is guaranteed tomorrow. Earthquakes don't follow calendars. But scientists agree the fault remains fully capable of producing another giant rupture. Computer simulations suggest violent shaking could last several minutes. Entire coastal communities might have only minutes before tsunami waves arrive. Critical infrastructure could suffer widespread damage across the Pacific Northwest. This is why emergency drills throughout the region focus heavily on earthquake and tsunami preparedness. The next sleeping giant lies beneath one of the world's most famous volcanoes. Yellowstone. The word alone often sparks dramatic headlines claiming a civilization-ending eruption is imminent. Science tells a more balanced story. Yellowstone is indeed a supervolcano. Its underground magma system has produced several enormous eruptions over the past 2.1 million years. The largest blanketed much of North America in volcanic ash. However, scientists monitoring Yellowstone emphasize something important. There is currently no evidence suggesting a supereruption is imminent. So why does it appear on this list? Because it remains an active volcanic system capable of future eruptions over geological timescales. Thousands of earthquakes occur beneath Yellowstone every year. The ground slowly rises and falls. Hot springs shift. Geysers change behavior. These are normal signs of a living volcanic system. The challenge is that supervolcanoes operate on timescales far beyond human civilization. Their eruptions are extraordinarily rare but unimaginably powerful. If one eventually occurred, ash could disrupt aviation across continents, damage agriculture, contaminate water supplies, and affect global climate for years. Fortunately, scientists continuously monitor Yellowstone with one of the world's most advanced volcanic surveillance systems. Their goal is early detection, not because an eruption is expected soon, but because understanding Earth's most powerful volcanoes is essential. Far across the Atlantic, another danger lurks beneath the Mediterranean. Mount Vesuvius. Nearly 2,000 years ago, its eruption buried Pompeii and Herculaneum beneath volcanic ash and pyroclastic flows, preserving entire cities in astonishing detail. Today, millions of people live within reach of the volcano. Vesuvius remains active. Although it has experienced smaller eruptions since antiquity, its last major eruption occurred in 1944. Volcanologists constantly monitor gas emissions, ground deformation, seismic activity, and temperature changes. Modern evacuation plans exist because authorities recognize the enormous population now living nearby. Unlike many remote volcanoes, Vesuvius presents a unique challenge. Urban expansion has placed millions close to one of Earth's most dangerous volcanic systems. Scientists cannot predict exactly when another major eruption will occur. But they know it will erupt again someday. Preparing before that happens could save countless lives. Sometimes the greatest threats don't come from mountains. They come from water. The Indian Ocean earthquake and tsunami of 2004 shocked the world. More than 230,000 people lost their lives after a magnitude 9.1 earthquake generated massive tsunami waves across multiple countries. One lesson became painfully clear. Subduction zones can remain quiet for centuries before releasing extraordinary energy. Several similar regions around the world remain under intense scientific observation. One is the Sunda Megathrust near Indonesia. This immense fault produced the devastating 2004 earthquake, yet researchers believe neighboring segments remain capable of future giant earthquakes. Indonesia sits atop one of Earth's most complex tectonic intersections. Frequent earthquakes occur because multiple plates constantly collide beneath the archipelago. Scientists have significantly improved tsunami warning systems since 2004. Ocean sensors, seismic networks, satellite communication, and international cooperation now provide faster alerts. Yet warning systems cannot eliminate risk. Communities nearest the epicenter may still have only minutes to react. Preparation remains humanity's strongest defense. Moving beneath the ocean once again, another colossal threat exists along Japan's southern coastline. The Nankai Trough. Japan is arguably the world's most earthquake-prepared nation. For good reason. Historical records extending more than 1,000 years reveal repeated giant earthquakes striking this region approximately every 1 to 2 centuries. The last major events occurred in 1944 and 1946. Researchers studying geological evidence believe enormous stress continues accumulating beneath portions of the fault. Government agencies regularly conduct nationwide disaster simulations. Sea walls have been strengthened. Buildings follow some of the world's strictest earthquake-resistant engineering standards. Schools practice evacuation drills. Public awareness remains remarkably high. Despite these preparations, experts acknowledge that a future Nankai earthquake could still cause extensive destruction because of the sheer scale of the event. Nature often exceeds human expectations. Our next destination takes us beneath the ice of Iceland. Iceland sits directly atop the mid-Atlantic ridge, where North America and Europe slowly pull apart. It also rests above a powerful mantle hotspot. The combination creates one of Earth's most volcanically active regions. Recent years have seen multiple volcanic eruptions, reminding scientists that Iceland's geological engine remains highly active. One volcano receives particular attention. Katla. Hidden beneath the Myrtlesjökull glacier, Katla has a history of explosive eruptions capable of melting vast quantities of ice almost instantly. The resulting floods, known as jökulhlaups, can send torrents of water racing across the landscape with incredible force. Katla has remained relatively quiet for over a century. Volcanologists carefully monitor seismic activity, ice movement, gas emissions, and ground deformation. An eruption wouldn't necessarily trigger global catastrophe. But locally, it could produce dangerous floods, ash clouds, and disruptions to international air travel. The 2010 eruption of Iceland's much smaller geological volcano demonstrated how volcanic ash can ground flights across Europe. Katla possesses even greater potential. Now let's travel to South Asia, where one of Earth's least appreciated natural hazards quietly grows every year. The Himalayan region. When India collided with Asia around 50 million years ago, it created the tallest mountain range on Earth. The collision never stopped. India still moves northward. That movement continuously builds enormous stress along faults beneath the Himalayas. Major earthquakes have struck Nepal, northern India, Pakistan, Bhutan, and Tibet throughout recorded history. The devastating Nepal earthquake of 2015 claimed nearly 9,000 lives. Yet geologists believe some sections of the Himalayan fault system have not experienced their largest expected earthquakes for centuries. This doesn't mean disaster is imminent. It means tectonic strain continues accumulating. Rapid urbanization, dense populations, and vulnerable infrastructure increase potential consequences. Scientists use satellite measurements accurate to mere millimeters to track crustal movement across the mountains. Every tiny shift reveals more about the immense forces shaping Earth's highest peaks. Across the Atlantic, another restless giant rises above the Caribbean. The Cumbervieja volcanic ridge on La Palma in the Canary Islands gained worldwide attention after its 2021 eruption. Although dramatic speculation once suggested a future collapse might generate an enormous Atlantic tsunami, current scientific evidence indicates such extreme scenarios are considered highly unlikely. Nevertheless, volcanic islands remain dynamic systems. Lava flows, earthquakes, ash emissions, and localized landslides continue posing genuine hazards. Scientists study these processes carefully because understanding volcanic instability helps improve hazard assessments worldwide. Perhaps the greatest lesson is how science evolves. Early hypotheses become refined as new evidence emerges. Good science isn't about sensational claims. It's about following evidence wherever it leads. Finally, we arrive at perhaps the most overlooked threat of all. Extreme solar storms. Unlike earthquakes or volcanoes, these disasters don't begin on Earth. They begin 93 million miles away. Our sun constantly releases streams of charged particles into space. Occasionally, enormous eruptions known as coronal mass ejections blast billions of tons of plasma toward our planet. In 1859, the most powerful recorded solar storm, the Carrington event, caused telegraph systems to fail across Europe and North America. Operators received electric shocks. Some equipment caught fire. Auroras illuminated skies far closer to the equator than normal. At that time, humanity depended very little on electricity. Today, our civilization depends on it completely. Satellites, GPS, internet infrastructure, power grids, air traffic, financial systems, communication networks. Modern technology is deeply vulnerable to severe space weather. Scientists continuously monitor solar activity using space observatories positioned between Earth and the Sun. Fortunately, they can often provide advance warning measured in hours or days before the strongest solar particles arrive. Power companies, satellite operators, and governments increasingly incorporate space weather into emergency planning. The question isn't whether the sun will produce another major storm. It certainly will. The uncertainty lies in whether Earth will be directly in its path. Looking across all these threats reveals an important pattern. None of them can be prevented. Nature doesn't negotiate. It doesn't recognize borders. It doesn't distinguish between rich and poor nations. Yet humanity is far from powerless. Every disaster on this list has inspired remarkable scientific advances. Better satellites. Smarter computer models. Denser seismic networks. More accurate GPS systems. Improved building codes. Faster tsunami warnings. More effective evacuation planning. Entire international collaborations now exist because understanding natural hazards requires global cooperation. The phrase overdue often creates misunderstanding. It does not mean a disaster is late according to a schedule. Earth doesn't operate like a clock. Instead, overdue describes systems that have gone longer than their average historical intervals without releasing accumulated energy. Some may occur next week. Others may remain quiet for centuries. Probability is not prediction. This distinction is one of the most important principles in modern Earth science. Researchers communicate these risks not to frighten people, but to encourage preparation. History repeatedly demonstrates that informed communities recover faster than unprepared ones. The greatest tragedies often occur not because hazards exist, but because societies underestimate them. When scientists install another seismometer, launch another weather satellite, map another fault line, or monitor another volcano, they are quietly extending humanity's ability to coexist with an unpredictable planet. Earth has always been dynamic. Mountains rise. Continents drift. Volcanoes reshape landscapes. Earthquakes redraw coastlines. Storms redistribute oceans. These forces created the very world we inhabit. They are neither malicious nor merciful. They simply are. Perhaps the most remarkable realization is this: despite living on one of the most geologically active planets we know, humanity has never possessed greater knowledge about the forces beneath our feet and above our skies. Every new discovery narrows uncertainty. Every improved warning system buys precious minutes. Every preparedness plan has the potential to save thousands of lives. Nature's greatest disasters may indeed be waiting. But so is humanity's greatest strength, our ability to learn, prepare, adapt, and face the unknown with science instead of fear. The Earth is still writing its story. And every day, scientists around the world are working to help ensure that when the next great chapter begins, humanity is ready to meet it.